The James Webb Space Telescope was finally launched into space by the European Ariane 5 rocket, lifting off from a tropical rainforest on a journey to the very edge of time. James Webb embarks on a voyage back to the birth of the universe, and it has already begun to revolutionize our understanding of space. Not only has the telescope arrived, but it is also rapidly changing the landscape of scientific discovery. Scientists are astounded as they watch the Big Bang Theory come under scrutiny due to the telescope's recent findings. According to renowned physicist Michio Kaku, we may need to rewrite our textbooks on the formation of the universe, as 6 peculiar galaxies have been discovered, leaving scientists puzzled. What does this mean for our understanding of the universe? Keep watching to find out. Beyond Earth, there lies an incredible expanse of space, seemingly limitless and mostly unexplored. Thanks to ongoing scientific research and discoveries, we are beginning to understand the complexities of the world we live in, leading to new questions about the universe, its formation, and our own existence. Are we truly alone in the cosmos? Such questions have driven significant investments in space technology, leading to groundbreaking achievements like rockets and satellites orbiting our planet. One of the most significant recent accomplishments in astronomy is the James Webb Space Telescope, JWST. This large space-based observatory, designed to succeed the Hubble Space Telescope, is a collaborative project between NASA, the European Space Agency, ESA, and the Canadian Space Agency, CSA. Named after James E. Webb, NASA's administrator during the Apollo program, the JWST is designed to observe the universe in the infrared spectrum, allowing it to peer through dust clouds and study distant objects with unprecedented clarity. The JWST features a primary mirror that is 6.5 meters, 21.3 feet, in diameter, more than twice the size of Hubble's mirror. This large mirror enables the telescope to gather more light, providing higher resolution images. The near-infrared camera, NIRCam, produces sharp images of astronomical objects, including distant galaxies and star formation, and it also detects exoplanets. The telescope's mid-infrared instrument, MIRI, operates in the mid-infrared range, allowing the JWST to study the early universe, star and planetary system formation, and the atmospheres of exoplanets. The Near-Infrared Spectrograph, NIR-SPEC, performs spectroscopic observations, examining the formation and evolution of galaxies, stars, and the chemical compositions of exoplanets' atmospheres. Finally, the Fine Guidance Sensor, Near-Infrared Imager and Slitless Spectrograph, FGS, NIRIS, provides precise pointing and stabilization for the telescope while also conducting scientific observations, including exoplanet studies and star formation. So far, the James Webb Space Telescope has exceeded expectations. It not only provides clearer insights into the truths of space but has also begun to challenge long-held beliefs about the universe. NASA's recent release of data from the telescope revealed 6 mysterious and incredibly ancient galaxies, prompting Michio Kaku to remark that we may need to rethink everything we thought we knew about the universe's formation. These findings raise serious questions about the Big Bang Theory. The scientific community, especially on social media platforms like Twitter, has been buzzing with discussions of the shocking discoveries from the JWST's first set of data. Scientists are now grappling with the possibility that much of what we believed about our universe might be incorrect. One of the biggest implications of these discoveries is for the Big Bang Theory, which has long provided the dominant explanation for how our universe began. The Big Bang Theory posits that the universe began as an extremely hot and dense singularity about 13.8 billion years ago, followed by a period of rapid expansion known as cosmic inflation. This theory, first proposed in the 1920s by Belgian physicist Georges Lemaitre and popularized by astronomer Edwin Hubble's observations of the universe's expansion, suggests that the universe cooled and became less dense as it expanded, allowing matter and energy to form. The theory is supported by observations of cosmic microwave background radiation, CMB, first discovered in 1965, and the redshift of distant galaxies, which indicates the ongoing expansion of the universe. However, the recent discovery of 6 fully formed galaxies that appear to have developed only 500 to 700 million years after the Big Bang has left scientists questioning the established timeline for galaxy formation. According to our previous understanding, galaxies take billions of years to form, so finding these ancient, fully developed galaxies is a significant challenge to the Big Bang model. The JWST's discoveries suggest that galaxies may have formed much earlier than previously believed, raising new questions about how the universe evolved in its early stages. The recombination and reionization stages of the universe's development provide additional context for these findings. The recombination phase occurred about 380,000 years after the Big Bang, when the universe had cooled enough for protons and electrons to combine and form neutral hydrogen atoms. This process allowed photons, or particles of light, to travel freely through space, making the universe transparent for the first time. This event is significant because it marks the origin of the CMB, which provides a snapshot of the early universe. After recombination, the universe entered a period known as the Dark Ages, during which there were no stars or galaxies to emit light. It was only a few 100 million years after the Big Bang that the first stars and galaxies began to form, emitting intense ultraviolet radiation and ionizing the intergalactic medium's neutral hydrogen atoms. These new findings from the James Webb Space Telescope challenge our understanding of how quickly galaxies formed and how early they appeared in the universe. While the Big Bang theory has long been a foundational explanation for the universe's origins, the recent discoveries suggest that we may need to revise our understanding of the early universe. The telescope's data raises new questions about how the universe evolved and may lead to groundbreaking changes in our knowledge of cosmic history. The high-energy photons from stars were powerful enough to strip electrons from hydrogen atoms, resulting in the ionization of neutral hydrogen. This process is known as reionization. Reionization is considered a significant event because it marks the universe's transition from a predominantly neutral state to an ionized state. The ionized gas allowed light to travel freely, making the universe transparent once again. It also played a crucial role in the formation and evolution of galaxies and other large-scale structures in the universe. It is generally believed that reionization occurred gradually over several 100 million years, starting in small regions where the first luminous objects formed and eventually spreading throughout space. As the first stars began to form, simpler elements like hydrogen and helium came together to create them. These stars were massive because they lacked heavier elements, making them far larger than our Sun, sometimes dozens or even hundreds of times its size. These were the first population 3 stars. However, they remain unseen by us because our telescopes aren't powerful enough to detect them yet. Astronomers estimate that these first stars appeared about 560 million years after the Big Bang. Eventually, these first stars exploded as supernovae, and even larger stars formed and exploded too. Given the universe's condition and the star's composition at the time, it was a common occurrence to witness stars explode, lighting up the universe during the reionization period. During this period, most of the universe was composed of hot plasma. This idea is fundamental to the Big Bang theory, and over the years, this theory has been supported by various lines of evidence, including the observation of the cosmic microwave background, CMB, the abundance of light elements, and the large-scale structure of the universe. We've been taught this theory all our lives, and it has shaped our understanding of the universe. However, the theory is now facing challenges. But why? The discovery that has caused this disruption was made by the James Webb Space Telescope. Launched in 2021, the James Webb Telescope quickly gained attention for its stunning photographs of space, which have amazed scientists. Among these are clear, mind-blowing pictures of Copia supernova, Uranus, Neptune, the Pillars of Creation, the Pandora cluster, and strange galaxies, all captured with unparalleled clarity. These images have provided a deeper understanding of space. However, a recent discovery by the James Webb Telescope has been particularly breathtaking and is causing a significant shift in our long-standing beliefs about the universe. One of the most recent and astonishing discoveries made by the James Webb Telescope involved the observation of 4 of the strangest galaxies ever recorded, located over 13 billion light-years away from Earth. This discovery is remarkable and almost unbelievable, as it provides a glimpse into the infancy of the universe that is much different from what we had anticipated. These galaxies formed just 300 to 500 million years after the Big Bang, a time during which no galaxy was expected to exist or even be forming. This discovery has greatly contradicted our current scientific understanding of galaxy formation. The shocking revelation suggests that these galaxies formed during the dark ages of the universe and somehow survived explosions. From the evidence, it appears these galaxies existed at a time when nothing was supposed to exist. This remarkable finding came from two recently published studies in the prestigious journal Nature Star. The excitement surrounding these newly discovered galaxies is not without reason, as previous studies using the James Webb Telescope had hinted at even older galaxies. However, these four newly confirmed ancient galaxies stand out from the rest. Astronomers have rigorously verified that these are primordial galaxies and not some other cosmic phenomena masquerading as distant galaxies or nearby imposters. Yet, some scientists remain skeptical, with some suggesting that these galaxies could be black holes. But how true is this? For clarity, black holes are extremely dense objects with gravitational fields so strong that not even light can escape their pull. They are formed from the remnants of massive stars that have undergone gravitational collapse and are often found at the centers of galaxies. When a massive star runs out of nuclear fuel, it can no longer sustain the outward pressure generated by nuclear fusion, which balances gravity. Without this pressure, the star's core collapses inward, releasing enormous amounts of gravitational potential energy, which leads to a supernova explosion. Different types of black holes form depending on the mass of the collapsing star. Black holes have several defining characteristics, including a region called the event horizon, beyond which nothing can escape, and a gravitational singularity at their center where current physical laws break down. They can also be surrounded by an accretion disk of gas and dust that emits radiation before crossing the event horizon. However, scientists assert that these newly discovered galaxies cannot be black holes, as they would also defy our understanding of black holes. So how did the James Webb Telescope manage to spot these galaxies? Traditionally, astronomers estimate the redshift of nearby galaxies, which indicates their distance from us as the universe expands, based on color variations. However, this method becomes less reliable when exploring uncharted cosmic territories like those observed with the James Webb Telescope. In a remarkable feat, researchers employed detailed measurements of the galaxy's spectra, analyzing the range of light emitted across different frequencies. This allowed them to double-check the accuracy of the redshifts and confirm the authenticity of these ancient galactic entities. These four galaxies exist in a significant epoch known as reionization, during which the first stars are believed to have emerged. Once the ages of the galaxies were determined, researchers found that the stars within them were relatively small compared to those in our own Milky Way. Despite their small size, these galaxies displayed astonishing rates of star formation. Stéphane Cholot, a researcher at the Astrophysics Institute of Paris, expressed his surprise at this early stellar activity, which defied expectations. Furthermore, these galaxies appeared to lack complex elements, suggesting their stars hadn't had enough time to create heavier elements. Instead, they consisted mostly of the original hydrogen and helium atoms that filled the early universe. These findings highlight the rapid growth these ancient galaxies experienced during the mere 300 million years of their formation, leading Professor Peter van Dokkum to conclude that these galaxies had to grow up fast, surpassing even the longevity of sharks. When the James Webb Space Telescope was launched in December 2021, astronomers hoped it would uncover the origins of the first galaxies. However, discoveries like these challenge previous assumptions and suggest that galaxies may have emerged even earlier than previously imagined. Given these breakthroughs, Professor van Dokkum speculates that the birth of the first galaxies might have occurred so early that even the James Webb Telescope's capabilities cannot observe them. It's fascinating how scientific exploration continually reshapes our understanding of the origins of the galaxy and the universe. Thanks to the diligent efforts and rigorous research of scientists, we have gained invaluable perspectives that have helped establish our understanding of the solar system, the formation of planets, and predictions about the future. However, recent revelations from the James Webb Telescope indicate that scientists may have missed something crucial in analyzing the universe's formation based on the Big Bang theory. These astonishing new galaxies have become a challenge to our existing knowledge and leave us questioning the origins of these unexpected cosmic wonders. Following the trend of groundbreaking discoveries by NASA's James Webb Space Telescope, it has gone further to unveil the universe's most ancient galaxy ever witnessed. Following the release of two preprint papers posted to a scientific article repository detailing the earliest analysis of this situation, the image released by NASA shows what looks like a red blob in the distance. But this is not just an ordinary blob, it is currently the oldest known galaxy in the universe, known as Glass Z13, taking its name from its redshift distance. This extraordinary celestial entity is said to have emerged a mere 300 million years after the cataclysmic event known as the Big Bang, surpassing its predecessor, the remarkable GN Z11, by approximately 100 million years. Glass Z13 has now claimed the title of the oldest galaxy on record, astounding astronomers. Glass Z13 is estimated to possess a mass exceeding 1 billion suns. Despite its colossal weight, this primordial galaxy is remarkably smaller than our own Milky Way, which stretches across a vast expanse of about 100,000 light-years. In contrast, Glass Z13 spans only a few thousand light-years. Remarkably, diligent researchers also stumbled upon another neighboring entity, Glass Z11, which shares the same ancient age as its predecessor. Both galaxies are relatively diminutive in size, with Glass Z13 measuring approximately 1,600 light-years in width and Glass Z11 spanning 2,300 light-years. Astronomer Rohan Naidu expounded on these extraordinary findings, stating that they had stumbled upon two compelling contenders for distant and ancient galaxies. The cosmic expanse between us and them is so immense that the universe was only a few 100 million years old during their formation. With the prospect of peering even deeper into the cosmic tapestry, thanks to the James Webb Space Telescope, the potential to detect galaxies less than 200 million years old looms on the horizon. The researchers assert that this endeavor holds significant importance in accomplishing the JWST team's mission to forge a comprehensive spatial map, marking a pivotal milestone in our cosmic exploration. Apart from the discovery of the four strange clusters of galaxies alongside the oldest known galaxy, shocking and weird-looking galaxy has also been discovered from the data released by the James Webb Telescope. This time, the galaxy is the tiniest ever found, and, according to scientists, it is not supposed to exist. This discovery goes against every previous model and standard thought to be met before a galaxy could exist. The galaxy is so small that it is only 16 kiloparsecs wide. This is one of the strangest things seen in recent times. To understand how small the galaxy is, one could compare it to the size of the Milky Way, which is about 40,000 kiloparsecs. The galaxy RxJ 2129Z95 is seen at a redshift of 9.51, and because of its distance, its image appears faint but was boosted by a 2.5 billion light-year galaxy cluster's gravitational light. Besides its size, another surprising aspect of this strange galaxy is how fast it creates stars. Indeed, this galaxy is a star factory, producing numerous stars at a rate that is quite alarming and impossible for galaxies much bigger than it. The galaxy is said to have formed between 500 to 550 million years after the Big Bang. While some have questioned the claim that this is a galaxy and not a star cluster, all evidence has proven positive in supporting the galaxy classification. While it is small for a galaxy, it is still far bigger than a mere star cluster. As some scientists try to explain why this particular galaxy is creating more stars than is realistic, others speculate that there may be a mechanism at work that causes it to produce stars at a rapid pace. On the other hand, it could be that we do not fully understand how stars form. But how did the James Webb Space Telescope manage to spot these ancient galaxies in the first place? We must give credit to the JWST for its incredible ability to capture what its predecessors failed to see. How did it do it? It all comes down to the telescope's ability to detect infrared light, which can be better understood using the redshift concept. Redshift refers to the phenomenon where light from distant celestial objects, such as galaxies or quasars, appears to be shifted toward longer wavelengths, specifically toward the red end of the electromagnetic spectrum. This occurs due to the expansion of the universe, which stretches the light as the space between the object and the observer expands. This stretching causes the wavelength of light to increase, leading to a shift toward longer wavelengths, corresponding to the red part of the spectrum. Redshift is closely related to the Doppler effect, which is observed with sound waves, where the pitch of sound changes as a source moves toward or away from an observer. Similarly, the wavelength of light changes as an object moves in space. In the case of redshift, the wavelength of light is stretched due to the expansion of the universe. Redshift has significant implications in cosmology, providing evidence for the expansion of the universe and being used to measure the rate at which galaxies are moving away from us. The redshift of light from distant galaxies can also help estimate their distance from Earth, allowing astronomers to study the large-scale structure and evolution of the universe. It is amazing that all these strange discoveries of ancient galaxies, long hidden but now found, are causing such uproar among researchers and scientists. This is just part of the first batch of data from the James Webb Telescope, released by NASA. This clearly demonstrates the peculiarities of the JWST and its capabilities, suggesting that there is much more to come. With many more galaxies likely to be discovered, we can only anticipate what is next. What do you think about these stunning, strange galaxies captured by the James Webb Space Telescope? Let us know your thoughts in the comments section below.